Suppose a lifeguard at this pool with diameter 40 meter wants to reach to someone who is drowning at this point, and the lifeguard is at this point, so it's just directly across the pool. Now the lifeguard swims at a speed v and runs around the pool at speed 3v, so 3 times faster. We want to find a function that measures the total amount of time it takes to reach the drowning person as a function of the swim angle theta. So we define this as theta, and then we want to find a function so that when the lifeguard swims to this point B and then runs along this pool to this C, second part is to minimize the time, find an angle that minimizes the time. A few hints. First of all, a little geometry is involved. Say suppose this point O is the center of the pool, and then let's connect this to OB, and geometry says this angle is going to be 2 theta, and the reason is this is radius, this is also radius, and these two, and this is a isosceles triangle, therefore this is theta, this is theta. This external angle equals the sum of these two angles, so actually this is going to be theta, right? And so therefore with that we do know that what is the arc of BC, the length of arc BC, this is equal to the radius times the angle. In this case will be the radius is, because we do know the diameter is 40 meters, so the radius is just 20, so 20 times the angle, which is 2 theta, which is 40 theta. So that's hint number 1. With that, with the distance here, you would be able to find the time it needs from B to C. Now let's take a look at figure out the distance AB, the length of AB. Let's do a little geometry here. First of all, it's isosceles triangle, and then let's find this connect the center to the midpoint of AB. Then you will form a perpendicular. These two segments will be perpendicular, and let's call this as D. Let's label this as point D. Use a little trigonometry, we can find out AD, because we do know the radius is 20. This is angle theta, so therefore AD should be equal to 20, which is AO times cosine theta, right? If you cannot see that, you can quickly do that. AD adjacent over the hypotenuse, which is AO, should be equal to cosine theta, and therefore that's from this triangle. Therefore AD is cosine theta times AO, and AO is the radius, which is 20. So that's how you get to this relationship. Now which means AB, length of AB is twice of AD, which therefore is equal to 40 cosine theta. With these two segments, we now should be able to find the total time, which is the sum of the you just swim, which is the time it takes for the lifeguard swims from A to B, and plus the time for the lifeguard to run from B to C, right? You do know the speed from A to B swim is V, and then from B to C is 3V. So that's my hint. You should be able to use the distance divided by speed for the swim, and then plus another distance divided by speed for for the running, right? Okay, so that's my hint. I hope that you should be able to set up this function in terms of theta, because you do have those two, the length of those two portions, like arc BC and length of AB. Please keep in mind that theta should be from 0 to pi over 2. Just think about that. When theta is 0, AB, the theta is the angle formed by, when theta is 0 here, right? So AB coincide with AC, which means the lifeguard just swims across. And then when theta is pi over 2, in this case, this is pi over 2, that means the lifeguard just runs along the circle to the other side of the pool. So therefore this means swims across, right? Only swim. The other one just run. Okay. All right. The 328, problem 328, once you have the function, you just want to minimize this time. So that's where the derivative comes in, and I'll let you finish the rest of the problem. But this is the hint.